PSImetals has an artificial intelligence framework to implement industrial intelligence solutions. This framework connects PSI applications with an open-ended collection of AI and data mining engines such as R, Python or Qualicision. The algorithms are embedded as a service through an enterprise business bus, the PSI bus. Also, PSImetals' predictive quality solution uses machine learning based on this framework. Besides a framework for machine learning, we also need a methodology and best practice to implement predictive quality solutions. We call it the predictive quality pipeline. It starts with historical data acquisition, the collection of digital information about production orders and production steps, like process data, quality information, defect details, and so on. Data preparation is required to format and align all this raw data into one consistent model, which can be used to train a defect prediction model. Now we can start training one or multiple prediction models using various machine learning methods. These prediction models are further evaluated and compared by the use of prediction key performance indicators. The best performing prediction model is used for the online prediction system that will feed the prediction model with actual production data in order to predict defects. The PSImetals factory model beholds most of the required data needed for training a predictive quality model. It has access to production orders, produced, finished and semi-finished material units, production quality data including the defected material units, L2 process data and so on. This material genealogy, the production quality and the production process data can be linked together into one consistent historical production and defect dataset in order to train the defect prediction model. We call this the quality data matrix along the whole production chain. Let us look at an example. Suppose that we want to predict defects just after completing the hot strip mill production step. If we can predict quality defects at this stage of production, most of these defects can be avoided by rerouting, refactoring the remaining processes, or reallocating the hot coil. It could reduce the defect rate drastically. Typically, the following data features can be extracted from the PSImetals production management system in order to make a defect prediction that normally only could be detected after galvanizing or painting. A selection of these data features will be used to feed the training engine. Before training, we will split the historical dataset into two parts, a partition to train the prediction model and another partition to validate the prediction model. Typically 75% is used to train, 25% is used to validate the prediction model. Different machine learning algorithms exist side by side. They behave differently and so also the resulting prediction models will predict defects differently. The most used algorithms for prediction are gradient boosting, regression and random forest. Before deciding which method is the best, we need to validate and compare the resulting prediction methods. The validation data will be used to analyze the quality of a prediction model. We distinguish three main model validation key performance indicators. Very important to qualify a model are the predictions that were correct, or the true positives, but also the wrong defect predictions called the false positives. The precision KPI is a ratio of the number of true positives divided by the sum of the true positives and false positives. It says how precise the prediction is. If we predict a defect, will it be correct? The recall KPI is calculated as the ratio of the number of true positives divided by the sum of the true positives and the false negatives. It indicates the sensitivity of the prediction. What defects did we miss predicting? The receiver operating characteristic curve, or ROC curve, summarizes the false positive rate, the x-axis, versus the true positive rate, the y-axis. The higher the surface under the curve, the better the prediction model. The prediction key performance indicators are used to select the best prediction model to be used for operational prediction. Once we have a prediction model, this can be used to analyze the relative importance of the data features. We can easily deduct the relative prediction power of many data features. We can also analyze how these data features are related or correlated in relation with defects. Here you can observe some data feature correlation analysis of a given defect prediction model. After selecting a prediction model, we can use it online to make operational defect predictions. We can, for example, select the latest produced hot coils and use the prediction model to predict defects in the later process. For all predicted defects, the quality expert can decide what to do: reroute, reassign, or re-engineer the remaining production routes. Prediction models typically only have a short lifetime, and their precision and recall decreases over time. Therefore, it is important to systematically monitor the quality of the prediction model and retrain it with more recent historical data from time to time. Retraining and validation can be fully automated. Thank you for your interest in predictive quality. PSImetals would be very happy to discuss these topics in further meetings and workshops.